All right, guys, you did have a lot of time to work, so it's kind of my time now. When you, guys, you had a lot of time to work. Now it's my time. Thank you, thank you. I'm over here in my calculator. What or how did you use your calculator in solving this problem? Okay, you graphed the function f of x. Any hints about graphing, or did you guys just type it in? You just typed it in? Did you use the really cool alpha y equals thingamabob? I would have. So the really cool alpha y equals thingamabob would let us go ahead and make these fractions nice and pretty. So I can do my alpha y equals fraction. Some of you don't do that with me a lot, and so maybe you forgot that was a thing. It's a very cool thing because when you don't use it, mistakes can happen. So I have my x cubed over 4. Now, as I'm putting it in, quick question, why did you get it in your calculator? What did you see on this graph that you knew you needed to go to the calculator for?
It's not all perfect and nice.
It's not all perfect and nice?
As in, there's your decimal.
Oh, good. Yeah, this function is really nasty because there's a polynomial part to it. There's a trigonometric part to it. So Tyler's saying, like, we knew we couldn't solve by hand. And then my other question, kind of where I was leading, is what were you looking for? And I think some of you guys said intersection, right? If any of you guys noticed, I think I left off the negative, didn't I? That's a bummer. Okay, 3 cosine x. Just in case you were borrowing someone else's calculator, make sure you're in radian mode, but I am. I just need to go ahead and, number 1, get rid of that guy because he's not in this problem. And number 2, I need to go ahead and, oh no. Oh, just kidding. The new programming is kind of nice. Have any of you guys ever, though? Thank you. Have any of you guys ever forgotten something in the front and started overwriting it? Okay. Do you know how to not have to overwrite your entire function? Second, delete. Second, insert. If you want to insert something, now I don't need to do it right now because the cursor's doing it for me, but if you ever needed to, you could always hit that second insert and put in whatever you need. That works. And as you guys noticed, thank you, thank you, thank you, I did combine 2 of my terms. So I need x squared over 3. Oh my goodness. 10 years later.
It's actually positive. Over 4. Yeah.
Struggle. Come on. I apologize for how long this is taking. Did not know it would take quite this long. Here's a good place, right? If I was to start typing, I would overwrite everything. But if I do second delete or insert, I can go ahead and insert what I need, like minus. I think I put a negative in, right?
Find a square with an area bigger than that inside of that curve.
All right.
I'm getting 6 points.
So I have my function, and then when we go ahead and graph the function, which we totally could do, I'm going to be in Zoom standard. Tyler, can you please stop competing with me? I would really appreciate it. Okay. As we graph our function, now I've paused it. I apologize for technology. Sometimes it does throw me off. We do what we can with the tools that we have. That's responsibility. What do we need to use our calculator for? Okay, some of you guys said intersection, but to be honest, that's not what I'm looking for. Not right now. You're right, eventually I need intersections for the bounds. You're totally right, but right now I have nothing to find intersection. I do zeros, but that has nothing to do with S, does it? Yeah, I need this and this. I need L, and we, the clue, know that L is the tangent line at 0. So some of you guys said derivative. That's a great way of looking at it. We have a couple different ways of doing it, but probably the easiest would be second, trace, dy dx, number 6. We can find the derivative at any point as long as we type in the value that we need, and we have the derivative, negative 0.49999999. Sarah. Skimming, and it has the slope of the tangent line will be the derivative. Well, it depends. If I was to find, You guys got this number, right? Like we have it down, negative 0.4999. Okay, keep me honest. Sarah, what you're thinking is that this 0 is the max, but the dealio is this is shifted a little bit. If I was to actually want to find the max, where the horizontal tangent needs to be, I think that's what you're thinking about. The max is going to be a little bit before 0. And I can tell because that line is sloped down, and if it was the actual max, if 0 was the actual max, it should have been flat. But look, the actual max is a little bit left. So a little bit left, the max is up here, and then it started going down. And that's where I am right here. So this is all a little bit that way. Does that make sense?
So, I'm sorry, when we derive, making up a derivative, that causes
The m. The slope of the line, because the derivative at any point is the slope of the tangent line at that point. So a little bit before that was the horizontal tangent line at the max, but now we've started to go down. These tangent lines will keep on getting lower until it starts coming back in this concave up portion. Does that make sense? Okay. So what's the big dealio with the m? What was the point? Yeah, didn't you say that we needed to find L? So who is L? Okay, what's y1? What'd you guys find out? How'd you find that out? You can either go second trace and you can do value, or you can from the graph just hit the trace button, and a shortcut is it lets you plug in a point and you can find value. It's at 3. Or you could have, if you really wanted to, you could have done alpha trace y1 of 0, which is 3. So however you do it, the y value is 3. So y minus 3 and x minus 0. You can also see it in the graph, right? 1, 2, 3, it seems to be 3. Maybe we should just double check. So now we actually have the line, and the line is y equals negative 0.49999999999, etc., x plus 3. So now what? Yeah, we can plug into the calculator, totally. We can actually get this picture and not just be guessing anymore. So when we go to plug in for y2, we can plug in our lines, so negative point. Just put a few 9s in there, and then we have x, and then we have plus 3. And when we graph it, thank you. Now are you guys good to find the intersections? Okay. And we already knew one of the intersections. What was one of the intersections already? 0. And then what did you guys find your second intersection to be? So we can go ahead and say L and f of x intersect at x equals 0. And what else did you give me? 3.3. Give me more than that.
It's 3.38987.
Why am I asking you for all of it? It's not the final answer, so I can't round it yet, right? So then when I go ahead and plug into my integral, I'm going to have for the area of S is equal to the integral, not volume, area, 0 to b of, what'd you guys plug in? What's the first function? No. It's L. L is on top. Because if you were to find the area, the function itself, I have to get in terms of y. Top minus bottom, I can leave it in terms of x. And so L is on top, and f of x is on bottom. Completely. Why? Because it just says the area of S alone. R was important back here, but we're only dealing with S. Does that make sense? Now, could you have been super snazzy and could you have gone ahead and actually plugged in the 0 to the 3.389867 of negative 0.4999999 x plus 3 minus x cubed over 4 minus x squared over 3 minus x over 2 plus, could you have done this? And the answer is totally yes. But they said write an integral expression that can be used to find the area of S. I could have left it with the B because I told them who B was. I could have left it with the L because I made an equation for L. I could have left it with F because they told me who F was. You could leave it like that and that would be okay. Does that kind of make sense? And here's another reason for doing that. Do you guys know how I put it in my calculator wrong? What if you wrote one little wrong thing just in copying it? What would they have to do? Take off a point. They'd have to say, I'm sorry, like, yeah, I see that you were right, but you made it wrong. I have to take off a point. That's one of the things with the AP grading. Okay, does that kind of make sense? But that last night, the goal wasn't area, was it? What was last night's homework? All right, open up, colored pen. Let's try to go over as many questions as you guys need or have. The evens. Past number 70, which we've already graded, the cross-sectional areas. I think we started at 6. Is that our first even? Yeah, let me zoom in. Okay. First things first, when you guys start grading, there are two different types of answers the book's giving. One of them is if you solved it by hand, you would not have gotten a decimal. If you solved it by hand, and then if you had used calculator. Now, you know there should be 3 decimal places, so 0.690 or 0.689, whatever it is. But this would have been the by hand answer that you should have gotten. This would have been the calculator answer. Do you think these can show up on the non-calculator portion? Yeah. Do you think they can show up on the calculator portion? Yeah, so we just have to be ready. So if your guys' answers don't match, I was helping a couple girls this morning that seem to get kind of lost when we grade homework. So just a quick reminder, when we grade homework, don't get lost in the, oh, I'm wrong, I'll figure it out later. Take this time. If you have the wrong answer, write down the right answer. Do that first. Write down the right answer first. Have the right answer. Then go back and say, okay, did mine look like theirs? For instance, looking at this, I see it has to be a washer. And I see it needed to be the function minus 0 squared for big R and 2 minus 0 squared for little r. Check your function. So get the function right and then get the answer right. And then why would you even write down this work here? I don't really see any reason to write this down because you need to go back and be like, wait, why did I not get this? That was the whole point. Can you get the beginning of the problem? Did you figure out the 2 bounds? Did you figure out the expression? Don't go writing all this because that's just cheating now. But see if you checked the first integral expression. If you got it wrong, write the right one. Then you might need to go back and look at it. But get down the right expression, get down the right answer if you're wrong. David. Does anybody have an answer for that? Because something drastic changed from here to here. Why did they change from going to negative 2 root 2 to 2 root 2 and all of a sudden just going 0 to 2 root 2 and doubling? Because of the picture, there's the even symmetry, meaning what's on this side copies what's on that side. So instead of having to plug in both of these, which they're like, ew, they're like, I can go halfway and double it. So it's literally a shortcut. We talked about it with even and odd symmetry. If you have even symmetry, if you don't want to plug in those numbers, it would have been right if you had just kept going. But they said, let's go from 0, which is so much nicer to plug in, and just double. So it was a shortcut. And then you guys see power rule. You see plugging in f of b. And then the nice thing, if you do that cool even symmetry thing, and it only works when there's symmetry. What's on one side copies the other. Then plugging in 0 is super easy. It's not even there. And then simplify. Solved what? I mean, I can come back and look. The answer is, I mean, the short sweet is that it's wrong. So I would get down the right answer and then check your integral expression and let me do that as I get them grading number 10. So far this year, we haven't really had typos in the calculus answer key. I know in pre-cal we did. But so far, this calculus one's pretty good. Let me check it. So which one was it? Number...
I had it ready. I was like plugging it in. See? Why is it 4y?
Oh, you're plugging in what they did? Oh, it's not square root of 2 pi.
Why is it 4y?
It's square root of 2.
Oh, I just thought.
You see it? Yeah.
Yeah. What did they do? See,
I think that'll work out. Now I get what you're saying. There you go.
I think
Anybody still grading 10, 40, or 44?
I have to find the dust.
Okay, a couple more seconds. Going okay, Zach? Do we have any more evens past number 44, guys? 74, okay. Anybody still grading these? Oh, okay. Sorry, I asked, but no one responded. Are we good? Okay. Number 46 ends up being pi over 5. Number 54, they give you the y, but I mean the answer is just little 2, little 4, little 1, little 3. On which one? There's definitely going to be some of this on the multiple choice. There probably will be one on the FRQ. There are some big topics once we really get into AP practice, which is next week and then after spring break. There are some big topics that could show up on FRQs, like area volumes, frequently do. Slope field differential equation frequently does. A word problem involving some sort of table with some sort of theorems like MBT, IBT, EBT, and like average rate or velocity or motion, like first, second derivatives. Usually, so there's some big topics, but the problem is they don't all always show up because they rotate them. So yes, it could be an FRQ, and you're going to see some more examples today in the sense of there are whole FRQs that are based on area volume. But it could also be in multiple choice for sure. Austin, you had a question. What's up, bud?
I'm confused on how do you know when you use the washer this method when you're not given a graph? It's an word problem. It says.
Was this an example? Was there no graph given?
There was no graph
Yeah.
given.
Okay.
So it's hard to determine which one was on the top.
Can we use calculator
And
for
then it's
all
hard
the
to
questions?
determine what
No. No.
But how's
I just said sometimes it could be calculator portion, sometimes it could be non-calculator portion. There are calculator multiple choice and there are non-calculator multiple choice. There are calculator FRQs and non-calculator FRQs. Hence why I make you do it by hand and then I show you calculator, right? But it's okay, let's talk about it. What were the graphs in this one? I think, wasn't it just 1 minus x squared and 1 minus x?
Yes.
Guys, that's algebra 1. Now, I'm not saying that it's super, super easy for all of you to graph it, but isn't that just an mx plus b? So couldn't you rewrite this to be negative x plus 1? I'm like, oh, easy. It's going to have an intercept of, and it goes down 1 over 1, down 1 over 1. 1 minus x squared. Isn't that just a parabola? And you could test by setting equal to 0 if you really want to. It's a parabola with a 0 at 1. And it's going to be, now, if you're like, I don't know what's going on, okay, set them equal to each other and find the natural bounds like I taught you to do, right? If you set them equal to each other, then we would end up with a positive x squared minus 1 minus x equals 0, which means I'm going to have x times x minus 1 equals 0. So they're going to intersect at 0 and at 1.
Wait, are you sure those are the graphs? Those aren't the graphs. It's
This is not the graph for that one.
I just looked at the book right now. It's
Oh, okay, perfect. Sorry, I assumed you guys would check me if I was wrong. So go ahead. What are the
okay,
graphs?
So it's really weird. So
That's okay.
basically,
Y equals?
They give you two graphs.
Good.
Y
What are they?
equals x squared and y
Good.
equals x.
Oh, it's even easier than I thought.
But wait. So that part was easy, but then they give you three areas. So they give you the area in between them.
give you the area in between them, which is
What I heard you guys say, though, is that how could we do it without graphs given to us? Can we use our calculator? And I was like, wait. We should know how to graph these two. So the first thing I heard that I was addressing was how do we, you should know how to graph these. Now, I do hear that they're giving you different, wait, that means they gave you graphs.
they gave you graphs, but they also
Okay.
they gave you
Different regions, yeah. You have one here, right, and you have one here.
Yeah.
This is R1, is that right? And this is R2, and this is R3?
It didn't make it, they said rotating the region.
Yeah, but weren't there different regions that they labeled? I saw someone's picture this morning, so it's right? Okay. So I get it, but they gave us 3 different regions. If it helps, you can go ahead and say, okay, this is going to be R1, the red one. This is going to be R2, the green one. And this is going to be R3, the blue one. Now, I wasn't saying this problem was easy, and I'm sorry if you heard that and got offended. I wasn't saying the problem was easy. I was just hearing, how can we do this without a calculator? I'm like, come on. This is the first forever card we ever wrote down from Algebra 1. Okay. We should get the graphs, but I agree this is confusing. For 46 is what we're talking about? Okay. For 46, what were they asking us to rotate?
46 was R2 about y equals 1.
Okay, so green, right? Around which one? Y equals 1? Okay, green. Okay, revolution arrow, right? Are we tracking? I told you guys, and I know that this is tricky, and that's why we're taking today just to go over homework questions and practice. You always start from the axis of revolution. Okay, now this one's weird, because when you start from the axis of revolution, all yesterday we were going straight up or straight right. But is there anything straight up or straight right? So we're going to go to the outermost edge. It just happens to be, in this example, down. So we're still doing what we did yesterday. Nothing's changed. We're starting with the axis of revolution. But instead of going straight up or straight out to the outer edge or straight left, we're going straight down. So I said yesterday, sometimes it's down. You just didn't realize it. And that's okay. Down, the outer. That is going to be. Why do I also have to ask? This red cannot count for green. It would be blank space. Well, they didn't ask us about R3. If you have a question, this one is specifically only saying look at R2 being revolved. The hard thing is they use this picture, I think, for multiple problems. Is that what it was? Okay. So in this one, you were only supposed to look at, so I would have, if I had been you guys, I would have drawn this graph 3 times, and I would have shaded 3 different regions. And I would have said R1, R2, R3. But I was trying to show you guys, okay, you could look at it 3 different ways, but you have to realize R2 is self-enclosed. It's just this guy. So this would be blank space, that would be blank space. No red, no blue, just this guy. Kind of like how we were just using S a second ago, and Sarah was like, what about R? No. Just look at S. So just looking at R2. Do you guys see from the axis to the outermost of the green and from the axis to the edge of the green? The edge of the blank space to the green or the inner edge? You can think outer edge, inner edge. Austin, does it make sense why you would have to do a washer because the green doesn't go flush against?
No, looking at it, actually, mine's more like question 31.
Oh, okay.
It's more like when it's,
But does this washer one make sense, though?
that one makes sense.
Okay. So then we would go ahead and just get, now wait. I'm surprised no one else had a question on 46, though, because number 1, it was weird you were going down, and number 2, it's weird because if you look at this big R, who's on top? Y1 is on top. So when you go to do your subtraction, the top is 1. The bottom is x squared. Top minus bottom. Now, some of you are like, well, I switched it, but it'll be okay, there's a squared. But what if this was a cross-sectional area and you didn't square it? So you would need to do top minus bottom appropriately. Now, I know On, you're saying absolute value, and if you were doing it by hand and able to solve it yourself, that'd be fine. But if you were matching it with a multiple choice answer that was given to you without absolute value, You would have to know who's on top, who's on bottom. And look at little r. Who's on top of the little r sliver? 1. Who's on bottom of the little r sliver? X. 1 minus x squared. R squared minus little r squared. Still top minus bottom. It's just kind of weird because you had to go down so the axis is on top. But that's all right. Still top minus bottom. Now, Austin, I heard you said number 30 what?
31.
There isn't an even thing, is there? Just because it's already up here?
Oh, actually, could you do, I'm going to say 44.
Okay, let me give you guys a second. Isn't there technically one more you have to check? Let me let you check number 74 real quick. The final answer is B. Is that the last even? B. B as in beta, or boy, or balloon. Anyway. Balloon. I couldn't think of anything else. Nope, it's B. Do you want to look at 74 since we're there, Charlotte? Okay. How many of you guys got B? Let me just see. Who got B for 74?
I don't know.
Okay, but only 2? Ay, ay, ay. All right, let's zoom in. It's all right. Let's just zoom in. Where is it revolving around? Did you draw a revolution arrow? You did? If you drew your revolution arrow, take what we just did. This example is so close to the one I just showed you. And then rethink the whole situation. Okay, take what we just did. Someone tell me what we need to think about next after drawing the revolution arrow. Top minus bottom, washer. Why did she say washer? Why did Sam get that? Look at all that. Look at all that blank space, right? The fact is there's any blank space, but there's so much blank space. Okay, so washer first of all. So can't I say, wait a minute, dx or dy? dE. Right? You can either memorize horizontal axis of revolution or give it horizontal depth. You wouldn't give it vertical, I don't know, horizontal depth. So I know dx. I know r squared minus r squared. If you don't know that, you need to memorize your forever card, right? What I need in front, that's very easily forgotten. Don't forget your pi. My bounds, ooh. How'd you get bounds of 0 and 3/4? What'd you do to get that? Oh, they gave it to you. But what could you have done to find it? Set them equal and solve. Is that okay? Natural bounds. Okay. Now, help me with big R. What do I think to get big R? Because I have people giving me functions, and you haven't started where you needed to start. How do we start thinking about big R? Start at the axis of revolution. Always start there. Just pick a point. Start there. Now, nope, nope, nope. Fine. To the outermost edge. Who would I connect to? The x squared. Who's on top? This guy. Top minus bottom. Now, wait a minute. Where'd it go? It's a typo. Right? It's a typo because they wrote it right there. You guys see it, right? Just as I was saying that the calculus book has been really good this year. Oh well. 4 minus 4x squared. I'm not done. That's just big R. Who's little r? Start at the axis. Go where? The edge of the hollow, or you can say the inner edge of the shaded. Who's that? But who's on top? Who's on bottom? It makes sense, yeah? That's what it has to be. You need the pi. Okay, now I'm just totally confused. Does anybody have what B actually was? I mean, you got it right. There was a pi there, right? Okay. I don't know why they just didn't write it nicely. Epic fail on number 74. But for my ones that got it, it was B. There was a pi, and that should be a 4. We should have said, what's wrong with the answer key going into that one? All right. You guys said number 31. Nathan, you had a question, though, on number what?
It was 44, but you were going to grab. But I think I can get it based off.
Based off of what we've done? It's weird though because this is an x equals 1, 1, right? Hold on, let's do it because it's right, left. Right, left is always weird in my head. I don't know about you guys, but right, left is weird for me. I think x equals 1 is a boundary, right? Is it revolving around y equals 0?
It was the same one as 46. It was that same graph. It was the regions.
Which region was it on this one though?
Is
R1 about x equals 1.
Yeah.
So R1 was this guy?
Yeah.
Okay, so I'm just going to shade him and leave the rest blank, right? Because we're only looking at him technically.
Yeah.
And we're shading around x equals 1. Okay, hold on. I have to erase my rotation arrow. Guys, help me. Disk or washer? Washer, right? Look at all that blank space. Why am I going to say dy? Give it depth. It's going to be, you can either memorize it's a vertical axis according to your forever card, or you can give it vertical depth. Okay, where do we always start? At the axis of revolution. Yeah. Left, right? Doesn't this make sense? Start at the axis and go to the outermost. Yeah? That's big R. What do I do for little r?
Did he go to the
Does that make sense?
But just a quick
Yeah.
question. Why wouldn't it go to the first?
Because we're only looking at this region. There were all these different regions. We're going only this region. So all of this we have to think of as blank space. Because this is our only shaded. So we always go to the edge of this shaded. So the outer edge and the inner edge, if that makes sense. And guys, oh, now, you can see it over there, but if I go to write it, who would big R be? Right. Does that make sense? Right, which is x equals 1, minus left, which would be x equals 0. So 1 minus 0 is big R. And then who's little r? Right, left. Now, if we do 1 minus x, is that going to match with my dy? So we have to go ahead, and even though we did say y equals x, remember we can also say, oh, then x equals, so 1 minus y. We have to get it in terms of y, or else it won't match this guy. So I didn't want to write the x, that's not going to match, but the y, oh, he'll be fine. Plug it in, plug it in. Austin, you were saying that they didn't even give you a graph for the one that you got stuck on, though, right? Perfect. So let's go ahead and let me get rid of. If you guys want to take a quick picture or write down the review, if you haven't started it yet, feel free to go ahead and get it down now, because maybe you can play out on it for the next 5 minutes if you don't have a question on 31. So if you want to start playing, are there tons of review problems that I gave you? Why? I want you to focus on them. I want you to make sure that you understand them by hand and with calculator. I want to give you time, right? But also at the end of notes, which we're going to do right now, you're okay. At the end of notes, after we do number 31, do you guys see that there are, the multiple choice we'll do tomorrow. Do I have quite a few FRQs that you can play with? I have quite a few FRQs that you can play with, okay? These are in the notes at the very end of notes. We're going to practice tomorrow some more AP practice with multiple choice, but I wanted to make sure that we had the idea of 6-2 down today. So I don't mind that today was not a lot of practice. I'm going the wrong way. Section 6.2, here we go. All right, number 31. Sorry, is anybody still writing down the review? There aren't too many. This is the original review, and this is the AP practice review. I mean, all the questions are good, but I just gave you 1, 5, 15, 23, and then 15. Okay, Austin, as they're writing it down, 31, what was the first function that they gave you?
Y equals x squared plus 1.
Okay.
And y equals negative x squared plus 2x plus 5.
Okay.
I think it's like 2x values.
Oh, so they gave you defined bounds too, huh? Okay, so for number 31, y equals just x squared plus 1, right? And then help me out with the next one. Y equals,
Negative x squared plus 2x plus 5.
and then the x's were.
X equals 0 and 3.
Are we okay, guys, seeing that these are defined bounds? Is that okay?
Yeah.
They've defined it for us. We're cutting here, all right?
Yeah, for that.
And then the x-axis. Okay. So then the x-axis would also be technically the equation y equals 0. The x-axis, y equals 0. Oh, revolving. I thought you were just saying bounded by. So it's about the x. Got it. So about. Okay. There's a pre-cal way and then there's a calculus way. Now, the nice thing is, no matter how you look at it, x squared plus 1 hopefully isn't bad. It's a parabola, and all this change has just been shifted up 1, right? So we could go ahead and get that guy graphed pretty quickly and just say, all right, I got you. But the one that's harder is this guy. Number 1, isn't he a concave down parabola because of the negative? Okay. If you remembered from pre-cal, you could actually find his vertex by doing negative b all over 2a. You know, his vertex will be at 1, and I could plug in 1, I can get k. This is pre-cal. Negative 1 plus 2 is 1, 1 plus 5 is 6. I could actually get that his vertex is 1 and 6. Let's see. 1, 2, 3. Pretty quickly, and then go ahead and try to sketch him. But we're in calculus. We don't necessarily need to remember these old formulas from pre-cal. Another way that we could have done it is we could have thought, okay, if I'm looking at this guy right here, we could have actually taken his derivative, and we could have figured out that his derivative is negative 2x plus 2. I could have set that equal to 0 to find the critical number, because if he's concave down, doesn't he have a max? So I could find that his max is equal to x equals 1. And shouldn't you guys have also found your intersections or your bounds?
Do we need to find the intersections?
Well, what if 0 and 3 were not the intersections? We might have had some problems. But did anybody figure out when the intersections occurred?
Yes.
Was it
2, 5.
at 2, 5?
The other x is negative 1, but it's not in the interval, so I'm just choosing 2, 5.
So the reason this is important is because if we see 0 to 3, the struggle is we have two different regions. We have this region and we have that region that both need to get spun. Yeah. So we're going to have to split up from 0 to 2 and then from 2 to 3. And then deal both of them washers. Does that make sense how I thought about it though? Bye guys. Work on your review. Come with questions. Yeah, probably a little bit right at the beginning. Are you okay, bud? Need some water? You okay? All right.